In this video we will demonstrate how to edit minor scan defects. Dental scans can sometimes present with small defects. These need to be repaired first before the model bases can be made. Defects include small holes or rips, and irregular borders with free-floating and excess mesh. We have split the editing scan defects into several short videos. Please follow these videos before constructing the model base. Let us begin by inspecting the scan. There is a hole in the palate. There is a rip in the posterior section with some free-floating excess mesh. The borders are fairly irregular, and there are several smaller holes in other areas. Editing scan defects is usually done in a systematic way. You can develop your own sequence, but it usually involves the procedures demonstrated in this video. First, we will begin by removing all the areas of the scan which are not required. This could often include deep sulcus areas, or even parts of the inner cheek in the molar areas, which tend to curl back over the teeth. You can also delete a deep palate if the palate is not needed. This will make the model shallower and the model will take less time to print. While this scan does not include any of these defects, we will briefly demonstrate how this is done. Left-click to select the scan and make sure it is highlighted. Navigate to the menu and press the Fast Edit tab. This will place the scene into an edit mode. The scan is also in a transparent mode. Now press the C key on your keyboard. The C key is the circular select function. By rolling your mouse wheel, you can increase or decrease the size of the selection area. By pressing the left mouse button down, paint over an area which you would like to delete. When done, right-click to deactivate the circular select function, then go back to the menu and press the Delete tab. This will delete the unwanted mesh. The next step involves filling all the holes in the scan. Select the scan, make sure it is highlighted, navigate to the menu and press the Fill Holes tab. This will plug all the holes in the scan. In order to get rid of any free-floating islands, you will need to enter into edit mode. Press the Tab key on your keyboard. Next, simply select one single face on the dental arch. We are letting Blender know that we want to keep the mesh of the dental arch, and that we want to delete the loose surrounding mesh. It is very important that you remember to select a single face on the dental arch, otherwise the function will not work. Go to the menu and press the Clean button. All excess mesh has now been deleted. To continue, we will turn the scene to view the scan from the front. In order to repair the rip, do the following. First, enter into edit mode. Select one single vertex on one side of the rip, then shift and left click to select another vertex on the other side of the rip. Ensure both vertices are highlighted, then press the F key on your keyboard. This will fuse the two vertices. The rip is now sealed with an edge and you can treat it like filling a hole. We will repeat the bridging over here. Navigate back to the menu and press the Fill Holes tab. All holes have now been filled. To inspect the mesh, enter into edit mode by pressing the Tab key. Notice here that the holes have been filled with only a few faces. Ideally, it is best to preserve the integrity of the mesh in all places of the dental scan. In order to mimic the mesh of the repaired section with the mesh of the surrounding areas, we will need to fill the area with more vertices. To do this, first exit the edit mode. Then use the Sculpt tab on the menu. Brush over the area where the hole used to be. When done, press the Exit button. In edit mode, notice how the mesh has improved. It is, however, slightly more dense in some areas. In order to even the mesh, you can use the dropper function after activating the sculpt mode. With the dropper, you can mimic the mesh of a particular area when sculpting. This time, drag the dropper to an area of the mesh you would like to mimic, then left-click to select that particular area. Again, brush over the defect. When done, exit the Sculpt tool. In edit mode, notice how the structure of the mesh has changed to mimic the surrounding area. With this, we will conclude the tutorial. The process of editing the scan usually follows a sequential process. First, highlight and delete the areas which are not needed. Then seal all the holes, and bridge all the rips. Use the Fill Holes tab to plug the holes. Finally, fine-tune your work with the sculpting tool. Thank you for watching this video. In this video you will learn how to trim away excess and unwanted mesh from a dental scan. Begin by pressing the Tab button on your keyboard. This will get you into edit mode. Since all the vertices are currently selected, deselect these by pressing the Alt and the A key. Next, navigate to the upper right-hand side of the 3D window to get you into transparent mode. Click on this icon over here. By pressing the T key on your keyboard, you will be able to open the menu on the left-hand side. Choose the first icon on the top. By pressing down on the left mouse button and by moving the mouse, you will be able to access various selection tools. There is a box, a circle, and a lasso tool. For this demonstration we will use the lasso tool. Move to the mesh which is to be deleted, then draw a lasso over the area. This will select all those vertices. Press the letter X on your keyboard, then scroll to Vertices and press Delete. Another option is the Circle Selection tool. The shortcut key for the circle is the letter C on your keyboard. By rolling the middle mouse wheel, you can change the diameter of the circle. To exit the Circle Selection tool, you can just right-click in the 3D window. Otherwise, you can always access the tool through the toolbar on the left-hand side. Again, highlight the vertices which you want to delete. Since the circle selection mode is still active in the toolbar menu, in order to deselect the tool, you'll need to go back to the menu and set the tool back to the tweak mode. Then press X on your keyboard, followed by the delete option. Press Tab to exit the edit mode, then also undo the transparent mode. In the next demonstration we will show you how you can delete large sections of unwanted mesh by using the Fast Edit button on the menu. The Fast Edit button is just beneath the alignment feature. To demonstrate we will press the Fast Edit button. This will place the scene into a transparent mode. From here, press the C key. The C key is the shortcut key for the circular selection tool. Wipe over the area you don't want to keep, then right-click to deselect the selection tool again. Navigate back to the menu and press the Delete button. This will get rid of the entire area. Thank you for watching this video. In this tutorial you will learn how to use the cutting tools. These can be found in the blue, the orange and the green section of the menu. The Arch Cutting tool is the most widely used cutting tool and is used to trim the borders of the scan. The Arch Cutting tool will be demonstrated in the model design tutorial and will not be covered in this tutorial. The new cutting tools require you to activate an additional Blender add-on. This is the Add Curve Extra Objects add-on. If you are not too sure on how to do this, please go back to the installation video. To begin, we will select the scan and turn it so that we can view it from the top. Use Shift and right-click to place the cursor. This will let Blender know where the cutting tool needs to be positioned. Navigate to the menu and press the Curve Cutting tab. A circular cutting tool is immediately placed in the location of the cursor. You can use the S key to scale the tool. You can use the G key to grab the tool and to relocate it. The curve cutting tool can be helpful for cutting out larger or smaller sections from objects. We will downsize the circle so that we can punch out a hole in this area. Navigate back to the menu and press the Keep Outside tab. This means that only the content within the circle will be cut out. At this stage, you can still press the G key to relocate the circle. In order to finalize the cut, you will need to navigate back to the menu and press on the Accept button. This is very important and cannot be overlooked. A hole has now been created in the scan. Next, we will demonstrate some extended features of the curve cutting tool. Again, place the cursor, Shift and right-click, navigate back to the menu, and press the curve cutting button. This time, we will select only one of the vertices of the curve. By pressing G on your keyboard, and by moving the mouse, you can relocate the vertex. This can be done for any of the other vertices as well. If you require more vertices, go back to the menu, and press the plus sign. In this way, you can shape the curve any way you like. When you are satisfied with your work, navigate back to the menu and press the Keep Outside, or the Keep Inside tab. This will immediately create the cut. The cut can still be relocated or rescaled slightly. To finalize the process, you will need to press on the Accept button. This is very important. Blender will take a few moments to do the necessary calculations, please be patient. This has created the cutout in the scan. To continue, we will place another cursor in this area over here. This time, we will press on the Square Cutting tab. In order to scale the Square Cutting tool, simply press the letter S on your keyboard. By moving your mouse, you can make the tool larger or smaller. Likewise, use the G key to grab the tool so that you can relocate it. By using the letter R on your keyboard, you can rotate the cutting tool. After this, we will navigate back to the menu and press the Keep Outside tab. At this stage, you can still grab the cutout and relocate it, as we did earlier on. When you are satisfied with the placement, press the Accept button. Next, we will place another cursor over here. Again, we will demonstrate the extended feature of the Square Cutting tool. We will navigate back to the menu and press the Square Cutting tab. To scale the tool, first select all the vertices. Press the letter A on your keyboard. The letter A will select all. Then press S for scale. By moving the mouse, you can increase or decrease the size of the cutting tool. If you require more vertices within the cutting tool, simply press the plus sign on the right-hand side of the menu. If you would like to change the shape of the cutting tool, simply select one of the vertices in the cutting tool, press the letter G, and by moving the mouse, you can relocate it. Left-click to set it down. Repeat this process for any of the other vertices in the cutting tool. After this, go back to the menu and press Keep Outside. To finalize the process, remember to press on the Accept button. Next, we will demonstrate how you can use the Square Cutting tool to cut out entire quadrants. Again, we begin by placing the cursor, Shift and right-click. Navigate back to the menu, and press the Square Cutting tab. To scale the tool, make sure all the vertices in the tool are selected. If they are not, press the letter A. This will select all the vertices. Then use the letter S to scale. Move your mouse to increase the size of the cutting tool. We will use the letter R to rotate the tool. This time we will choose the Keep Inside tab. Continue, and press on the Accept button. This will section the scan. This short video insert will demonstrate a small change which was made to the menu recently. The new update includes a vertex cutting tool and its corresponding slice button. The function of the other buttons in the menu remain the same. We will briefly demonstrate the vertex cutting tool. Make sure the model is selected, and you have placed the cursor. Press the vertex cutting tool button, then left-click anywhere in the 3D window. This will place a vertex in that particular area. Use the E key to extrude the line, then left-click to place another vertex. You can draw any shape you like. When done, press the Slice button. The Slice button will then allow you to place a value into it. In Live Edit mode, watch how the gap changes when you increase or decrease the value. To perform the cut, simply press the Accept button. The Slice button can also be used with all the other cutting tools. For example, you can use the Square Cutting tool to cut the periphery outline of the square. All you need to do is to set the gap clearance before pressing the Accept button. The Slice button has also been added to the Lasso feature and will perform the same function. In this demonstration, we will show how to use the Lasso cutting tool. Ensure the object is selected, then Shift and right-click to place the cursor. Navigate to the menu, and press the Lasso tab. Hold the left mouse button down, then lasso over the entire part which you would like to cut out. You can use the lasso in other areas at the same time. Go back to the menu, and press either Keep Outside or the Keep Inside tab. This will immediately cut out the section. Again, we will select the scan first. This time, by dragging out another lasso, we will choose to keep the inside instead. This has retained the required section of the scan. In this demonstration, we will show you how to perforate the walls of the hollowed-out model. This can be very helpful if you want to eliminate the suction cup forces created during the printing process. You can use the tilde key to view the model from the side. First select the model, make sure it is highlighted, then shift and right-click to place the cursor. This should be in the area where you want the cutting tool to appear. Navigate to the menu and press on the Square Cutting Tool tab. Scale the tool first. Press the letter A to select all the vertices in the cutting tool, if they are not already selected. Cutting tool, followed by the letter S. If you would like to duplicate the cutting tool, use Shift and the letter D on your keyboard. D is for duplicate. By moving the mouse, you will be able to relocate the duplicated cutting tool. Set it down with the left click of your mouse. Repeat this process as many times as you like. In order to do multiple cutouts in one go, you will need to make sure that all the cutting tools remain selected. Here we will use the A key to select all cutting tools, then by pressing the letter G, we can relocate all of them in one go. When this is done, navigate back to the menu and press the Keep Outside tab. At this stage, we can still use the G key to do further adjustments if necessary. Remember to press on the Accept button. This is very important in order to finalize the cutting process. Sometimes when using a Boolean cut in CAD software, the normals in an object can get switched around. A normal is best described as the outside surface of the mesh. If the normals get switched around, this means that the mesh is turned inside out. You may notice subtle changes in the surface color and shading of your model. To demonstrate a change in the normals, we will select the upper model. The correct normals can be seen by pressing the Face Orientation checkbox. If the objects are displayed in blue, the normals are correct. We will change the normals in the upper model by pressing the Flip Normals tab. Here you will see the upper model change to a red color. When this occurs, the mesh of the model is turned inside out. If you uncheck the Face Orientation checkbox, notice how the shading of the upper model differs slightly from earlier on. Most CAD programs incorporate this as a standard feature, so that the mesh of the objects can be inverted back into its correct position. Inverted normals may result in your work not printing or milling correctly. To check this, simply click on the Face Orientation checkbox. Always ensure the outer surface of the objects are displayed in blue, otherwise press the Flip Normals tab to get the mesh back into the correct orientation. With this, we will conclude the Cutting Tools tutorial. Thank you for watching this video. In this tutorial you will learn how to patch up stone models, especially bubbles. To begin, zoom into the area. Then, shift and right-click to place the cursor. Navigate to the menu and press on Patch Up. This will create a sphere which fits into the location of the cursor. By using the S key, and by moving the mouse, you can scale the sphere. Please note that the magnet widget needs to be turned on. This can be activated on the upper toolbar. The magnet tool will make one object stick to another object. Continue and press Shift D on your keyboard. The letter D means that you are duplicating the ball. Repeat pressing Shift D. This creates a series of balls which turn into an irregular oblong structure. We use this structure to clog up the hole. Once this is done, go back to the menu and press on the Fill tab. This will unify the infill with the dental model. The surface will be leveled further down the track. In the meantime, we will repeat the process for the next bubble. Shift and right-click to place the cursor, then press Patch Up. Use S to scale, and Shift D to duplicate the balls. If you would like to relocate the infill, first untoggle the magnet tool, select the sphere you would like to relocate. Press G to grab it, then simply move it to another location. Do the same for the other sphere. When you are satisfied with the outcome, press on Fill. Since the infill is still jutting out, we will need to level the surface. Navigate to the upper menu, and press the Sculpt tab. Move to the left-hand side, and access the Blender sculpting tools. Remember, this menu can always be accessed by pressing the letter T on your keyboard. In this situation, we will first make use of the Flatten tool, followed by the Smooth tool later on. By using the Flatten tool, and by rubbing over the area, you will be able to level the surface of the tooth. If you want to change the detail of the Flatten tool, simply move to the upper part of the window, and change the Dynatopo settings over here. Next, we will make use of the Smoothing tool. Repeat the same process, and rub over the area to smooth the surface. Going back to the other bubble, first use the Flatten tool. Rub over the area. Then use the Smoothing tool. With this, we will conclude the tutorial. Thank you for watching this video. This short video will demonstrate a recent update which was made to the Patch Up tool menu. The Patch Up tool can now perform an inverse function. This means that you can use it to carve a small section out of the dental model. To demonstrate, we will select an area over here. First, place the cursor, shift and right-click. Go to the menu and press the Patch Up button. This will immediately place a small sphere in the location of the cursor. Navigate back to the menu and press the Carve button. This will create a small indent in this area. This feature can be useful to create additional retention for removable appliances when there are not many undercuts present. Thank you for watching this video.